Hello everyone, I am RONAK SHRIMAL, Assistant Professor at Department of Electronics and Communication at Gitanjali Institute of Technical Studies Udaipur, which is affiliated to Rajasthan Technical University Kota. I am going to deliver my lecture on silicon control rectifier topic from a subject power electronics. The subject is according to RTU syllabus and its code is 6EC301. Let's start with the introduction and contents. The contents are: we will be discussing on history on thyristor, what is thyristor and its types, introduction to SCR, what is SCR, some little bit basics about SCR, how does SCR work, what are the characteristic curve of SCR, importance of SCR, and conclusion. Now let me tell you about the history on SCR. In 1950, silicon control rectifier or thyristor was proposed by William Shockley. Here I have used or between silicon control rectifier and thyristor, means previously only one device was there and it was named as thyristor, but day after day the new devices were developed on the basis of thyristor property, and we got different types of thyristor devices. So thyristor was become the thyristor family, and this thyristor family with different devices were developed. In this, first was the silicon control rectifier, which I am going to discuss with you all. It was developed in 1956 by power engineers at General Electric Lab. Earlier, gas-filled device called a thyratron tube was provided for the purpose of switching purpose, and the main thyristor is derived from the combination of two words, which is thyratron and transistor. So thyristor is a device which has the property of thyratron and transistor both. Now what is a thyristor? Actually, thyristor is a four-layered 3-terminal semiconductor device with each layer consisting of alternatively n-type or p-type material. For example, PNPN, we have taken 4 layers of p-type n-type semiconductor and merged it with one upon other, and we have given 3 terminals here. It comes with the 3 terminals: anode, cathode, and gate. Anode is the positive polarity, cathode having the negative polarity, and the third terminal is the control terminal, which is known as gate, and it is always connected to the p-type material. And the important thing is that the operation of the thyristor can be understood in terms of pair of tightly coupled bipolar junction transistor. Means thyristor can be considered as the two BJTs connected back to back. We can see in further slides. Now what is the general idea of thyristor? Thyristor can produce half wave and full wave rectification just like rectifier. As all we know, rectifier, we have studied half wave, full wave, and bridge rectifier, and it is used to for the conversion of AC into alternating AC into DC, but in 3 different modes: half wave, full wave, and bridge wave. We have studied in with respect to diode. We have used the diode in the circuit. Now what was the disadvantage in that? We don't have any control over the output, but by replacing diode with this thyristor, we will be having the control over the output, because we are having a thyristor with a third terminal gate, and which is a control terminal. So using a thyristor, it is better than diode for rectification, particularly used for controlling power circuits, simple to use, easy to build, and cheap. And the 3 terminal thyristors are anode, cathode, and gate, and it is a bistable device. These are the different types of thyristors which come in thyristor family. We will be dealing with first silicon control rectifier, second is gate turn off thyristor, GTO, third one is MOS control thyristor, and fourth one is static induction type thyristor. Now basically many semiconductor devices use different types of materials, but most of the time silicon is used. Why? Reasons for using silicon for thyristors: it is able to handle the voltage and current required for high power applications, as thyristor is basically used for high power applications. It has good thermal properties, well established, and is widely used for variety of semiconductor electronics. It is easy, cheap to use. Now I'll start with give you an introduction and a lecture on introduction to SCR. Now what is SCR? Silicon control rectifier. As the name suggests, silicon is used for is made, and its properties is like a rectifier. Now what is the property of rectifier? It's provide low resistance path in forward direction and high resistance path in reverse direction. Now this SCR is the electronic device which is unquestionable of the greatest interest today, and it was developed in 1956 by Bell Telephone Laboratories. It can convert alternating current into direct current, and at the same time can control the amount of power fed to the load. So it combines the features of both rectifier as well as transistors. Now what is silicon control rectifier? It is a again silicon control rectifier and thyristor is one of the same thing. Here is a 4-layer solid state device that controls the current flow. It has 3 terminals: anode, this is the symbol of thyristor, anode, cathode and gate. And the two main uses of SCR are switching and amplification. Switching, it can do fast switching, and it can also used to do amplifications. Now this is the let me discuss about the basic structure of SCR. This is the constructional view of silicon control rectifier. You can see different types of p-type and p-type n-type layers are arranged one above the above with the different doping concentration is given. The p-type, this n plus is given 10 to 19 number of electrons per centimeter cube, that is per unit volume. So it consists of 4 p and p-n type layer, 2 anode and cathode terminals, one is the gate terminal, okay, and the 3 junctions, it generally form 3 junctions, junction J1, J2, J3, and they are numbered serially with J1 being the nearest to the anode. Here you can see the basic structure. Here 4 layers are there: P1, N1, P2, N2, anode and cathode, and gate terminal. Gate terminal generally connected to positive p-type semiconductor. 3 junctions are there: J1, J2 and J3. You can also see these diagrams. In this diagram it is clearly shown that it can be analogous to 2 transistors connected back to back. Here now let's see this SCR looks like this. This is the basic structure. Now how does SCR work? SCR is connected in, load is connected in series with anode, and the anode is always kept at higher potential than the cathode. And the working of the SCR is to be studied under 2 different conditions. First is when gate is open, and another is when gate is positive with respect to cathode. Let me see in the diagram. This is a circuit diagram. In this diagram we can see that the anode, which is connected to P positive p-type semiconductor, cathode which is connected to negative terminal, that is n-type semiconductor. N-type has a majority of electrons and p-type has a majority of holes. They are both are connected to positive, this battery. Anode is connected to positive, cathode is connected to negative, but we have not given any voltage to the gate. So due to anode is connected to P, which is positive, and n-type semiconductor is connected to cathode, which is connected to negative terminal. So junction J1 and junction J3 becomes forward bias, but junction J2 becomes reverse bias because n-type is directly attracted towards this positive polarity of battery. So junction J1 and J3 will become forward bias and J2 will become reverse bias. So reverse bias means high depletion layer, and because of high depletion layer, high depletion width, its width is very maximum, so electrons and holes will not cross each other and the conduction will not be there. So there will no current will flow through the device because SCR is in this mode will be treated as cutoff. Now when gate is made positive with respect to cathode, here you can see same principle is there. Anode is connected to positive, cathode is connected to negative, but now here we have connected gate with the positive current. Because of this, now anode and cathode are connected to positive and negative of the battery. So junction J1 and J3 are forward bias, and we have junction J2 as reverse bias. Now our duty is to make this junction forward biased. Now how will be achieved? By connecting positive gate voltage by across this junction. What will be happen? Electrons from n-type material start moving across junction J3 towards the left. Similarly, holes move from p-type material towards the right, and eventually the electrons that moved across junction J3 are now attracted across J2, and this initiates the gate current, and the J2 is now conducting. So basically what will happen? The J2 will lose its reverse blocking capability and come into the forward conduction mode. So electrons and holes will cross over this junction and the current will start flowing from anode to cathode. This is the characteristic curve drawn basis on that what we have studied just before in before slide. Here the graph will be drawn between anode current and forward anode current and the anode voltage. Here you can see I have mentioned three regions: forward conducting region, forward blocking region, and reverse blocking region. Actually, the SCR is we have to understand the SCR working in three different modes. Uh, Now, what is reverse blocking mode? Reverse blocking mode is that we will connect anode with negative polarity of battery, cathode with positive polarity of battery. So the junction J1 and J3 becomes reverse bias, and junction J2 will become forward bias. So because of the two junctions will become reverse bias, the movement of electrons and holes will not be there, so the current will not flow. So in this mode, the thyristor will be off, or we can say it is in cutoff. Now next is the forward blocking mode. In forward blocking mode, we'll connect anode with positive of battery and cathode with negative battery. So junction J1 and J3 will become forward bias, but here also J2 will become reverse bias. So again the current will not flow. So in both the mode, the conduction will not be there. But in the same, if we have connected the thyristor in forward blocking mode. Now if we apply the positive gate voltage, what will happen? We have just shown that current will start flowing, and of this because of the gate voltage, the junction J2 has removed his reverse blocking capability. So what happened? As in this graph, you can see this is the forward breakover voltage. This is known as forward breakover voltage, means the maximum voltage after which the thyristor will come in the conduction mode. So when we apply the gate voltage, what will happen? The electrons and holes will move fast, and the voltage drop across the thyristor will drop instantaneously, and the current will increase like showing in this graph. So this way the forward voltage will become minimum and the current will become maximum. So in these three different modes, the thyristor will work. So the thyristor has three basic states: forward blocking mode or off state, forward conduction mode or on state, and reverse blocking mode or off states. Now what are the importance of SCR? It is small size and gives trouble-free service, reliable fast action and lightweight, and no mechanical part or noiseless operations. Now what are the applications of SCR? It is used in rectification, regulated power supplies, static switches, motor speed controls. We can control the speed of a motor using a thyristor, because we can even in induction motors and DC choppers, all will use this thyristors, battery charger, heater control, etc. Now what is the conclusion? Finally, silicon control rectifier are widely used in many areas of electronics. SCR circuits can be used for many power applications, as these electrons components are able to switch high currents very easily, and in addition, these electrons components are very cheap and they are widely available. So guys, thank you.